When you're driving down the road and hit a bump, ever wonder why your car doesn't bounce like a basketball? That's thanks to the suspension system. It's one of the unsung heroes of every vehicle, working constantly to keep your ride smooth, your tires firmly on the road, and your steering under control. At its core, a suspension system is designed to absorb shocks and vibrations from the road. Without it, every pothole and uneven surface would transfer directly to you, and your vehicle would be incredibly difficult to handle. The system is made up of several key components: springs, shock absorbers, and linkages that connect the vehicle to its wheels. Each part plays a critical role in maintaining balance, control, and comfort. In this video, we're diving deep into the fascinating world of suspension systems, from the classic leaf spring to modern air suspensions, and exploring how each type has shaped the way we drive today. Let's start with one of the oldest and most iconic suspension components, the leaf spring. If you've ever looked under an old truck or carriage, you've probably seen it. A stack of curved metal strips layered on top of each other like a bundle of flat rulers. Leaf springs work by flexing when the vehicle goes over a bump. As they bend, they absorb the energy from the road and help smooth out the ride. The stack design distributes the load across the spring, which is great for carrying heavy weights. That's why you'll still find them in trucks and commercial vehicles today. They're simple, durable, and can handle a lot of stress, but they're not the most comfortable. That's one of the reasons more modern vehicles have moved toward other suspension types. Still, leaf springs laid the foundation for everything that came after. Literally. Now, let's break down the key components of a leaf spring, because it's more than just a stack of metal. At the heart of the system is the leaf spring pack, a stack of curved metal strips, or leaves, that flex and bend to absorb shocks from the road. The main, or master leaf, is the longest and strongest leaf in the pack. It often has eyes at both ends called the front eye and rear eye, which connect to the vehicle's frame. These eyes are mounted to the chassis using mounting brackets. The front hanger keeps the spring fixed in place, while the rear hanger works with a shackle to allow the spring to flex as the axle moves. The graduated leaves underneath the master leaf are progressively shorter. Together, they distribute weight, support heavy loads, and increase durability. In the center of the spring pack is the center bolt, not labeled in this image, which holds all the leaves tightly together and ensures alignment. To keep the stack from fanning out or shifting under stress, rebound clips or spring clamps are added along the length. The entire spring assembly is mounted to the axle using U-bolts and a spring plate, locking everything in place securely. At both ends of the spring, bushings are installed inside the eyes. These rubber or polyurethane components absorb vibration and reduce metal-on-metal wear where the spring connects to the vehicle frame. Together, these components create a suspension system that's strong, simple, and built to handle rough terrain and heavy-duty use. Not all leaf springs are built the same. There are actually a few different types of leaf springs, each designed for specific needs and vehicle types. First, we have the multi-leaf spring. This is the classic version, made up of several steel leaves stacked on top of each other. The more leaves, the stronger the spring, which makes this type ideal for heavy-duty vehicles like trucks and buses. Then there's the monoleaf spring, also known as a parabolic spring. Unlike the stack design, this one uses a single, thicker leaf that's shaped in a parabolic curve. It's lighter and offers a smoother ride, which makes it great for modern vehicles that don't need to carry massive loads. Some variations even include semi-elliptical or quarter-elliptical designs, depending on how they're mounted and the kind of vehicle they support. Each type balances comfort, strength, and cost differently, and choosing the right one depends on the job it needs to do. The story of the leaf spring goes way back. Centuries, in fact. It's one of the oldest forms of suspension still in use today. Leaf springs were first used in horse-drawn carriages as early as the 18th century. Back then, they provided a huge leap in comfort over rigid wooden frames. These early versions were made of simple metal strips that flexed with the movement of the road, absorbing shocks and vibrations that would otherwise jolt the entire carriage. As vehicles evolved, so did the leaf spring. By the early 20th century, they became standard in automobiles and trucks, especially in heavy-duty applications. They were simple to manufacture, durable under pressure, and could support a lot of weight, making them perfect for industrial use. Even with the rise of more modern suspension systems, leaf springs have stood the test of time. They may not be cutting edge anymore, but their historical impact on transportation is undeniable. Now let's talk about the coil spring, or resort hélicoïdal in French, the suspension component you're most likely to find in modern cars today. Coil springs are exactly what they sound like: tightly wound metal spirals that compress and expand to absorb shocks from the road. When your wheel hits a bump, the spring compresses, storing energy. Then it releases that energy as it returns to its original shape, smoothing out your ride in the process. Unlike leaf springs, which are designed to handle heavy loads, coil springs are built more for comfort and handling. They're compact, lightweight, and allow for more precise control of a vehicle's suspension geometry. You'll often find them paired with shock absorbers or struts, which help dampen the bouncing motion that springs alone can't manage. Together, they create a smooth, responsive ride, whether you're cruising on the highway or weaving through city streets. The coil spring might feel like a modern innovation, but its roots go surprisingly far back in time. Early versions of helical springs date back to the 15th century, originally used in items like mechanical clocks and door latches. But it wasn't until the 20th century that coil springs found their way into automotive suspension systems. By the 1930s, car manufacturers began adopting coil springs in passenger vehicles, especially in the front suspension. The reason was simple. They offered better ride comfort, more compact design, and greater flexibility for independent suspension setups, something leaf springs couldn't easily support. As vehicles became faster and more refined, the demand for smoother handling and better road feel grew, and the coil spring met that challenge. Over the decades, they became a standard in modern automotive engineering, especially in sedans, SUVs, and sports cars. Today, coil springs are a symbol of comfort and precision, built on a legacy of centuries-old innovation. Coil springs might all look similar at first glance, but there are actually several different types, each designed for a specific function and ride quality. The McPherson strut is a common front suspension system in many modern cars. It combines the shock absorber and coil spring into one compact unit called a strut. This strut connects the wheel hub to the car's body, supporting the vehicle's weight and absorbing bumps from the road. Its simple and space-saving design makes it ideal for small to mid-sized cars, helping reduce manufacturing costs while still providing a comfortable ride. However, because of its simplicity, it doesn't offer as much precise control over wheel alignment as some other suspension types. Let's take a closer look at the double wishbone suspension, a system often used in performance cars for its precise control and stability. At the heart of this setup are two control arms, the upper and lower wishbones. These arms are shaped like a triangle or a wishbone, and they attach the wheel hub to the car's chassis. The upper control arm, located above the wheel, helps manage the camber angle. This is the tilt of the wheel as the suspension compresses or extends. That control is critical for maintaining grip during cornering. Below that is the lower control arm, which typically bears more of the vertical load from the car's weight. It also provides a mounting point for both the coil spring and the shock absorber. Speaking of which, the coil spring is usually mounted on or near the lower arm, and it functions to absorb vertical energy. Rigid axle suspension, also known as a solid axle or beam axle, is a setup where both wheels on the same axle are physically connected by a single solid beam. This means when one wheel moves, say over a bump, the other wheel is affected too. There's no independent movement like you'd find in modern car suspensions. The strength of this system lies in its simplicity and toughness. It's incredibly durable, easy to maintain, and excellent at carrying heavy loads. That's why it's commonly found in trucks, SUVs, and off-road vehicles. In many setups today, coil springs are added to improve ride comfort, replacing the old leaf spring designs. However, because both wheels are linked, ride quality and handling aren't as refined. You'll feel more body movement, especially over uneven roads or during cornering. Let's talk about the torsion bar. A torsion bar suspension system uses a steel rod, called a torsion bar, that acts as a spring by twisting along its length. One end of the torsion bar is firmly attached to the vehicle's chassis or frame, while the other end is connected to a lever or control arm that's attached to the wheel assembly. When the wheel moves up and down, like when you drive over a bump or dip, it causes the control arm to rotate. This rotation twists the torsion bar. Because the torsion bar resists twisting, it stores energy and provides a spring force that smooths out the ride by absorbing shocks. The amount of resistance depends on the torsion bar's material, diameter, and length. Let's talk about torsion beam.
A torsion beam is a type of rear suspension system commonly found in small front-wheel drive cars. It uses a U or H-shaped metal beam that connects both rear wheels. The beam twists slightly to absorb bumps, acting like a spring. It's simple, compact, and combines spring plus anti-roll bar functions.
Let's talk about pneumatic suspension. A pneumatic suspension, or air suspension, replaces traditional coil springs with air-filled rubber bellows, air springs. These are connected to an onboard air compressor and valves, which adjust air pressure to change the vehicle's ride height and comfort. When more air is pumped in, the vehicle rises. When air is released, it lowers. Sensors monitor load and road conditions, and the system adjusts automatically for optimal comfort and handling. It's used in luxury cars, SUVs, and buses for a smooth ride, and in trucks for load leveling. When choosing a suspension configuration, it all comes down to the vehicle's purpose. For small front-wheel drive cars, a torsion beam rear suspension is a great choice. It's compact, cheap, and easy to package, offering acceptable comfort and handling for daily use. If you want better ride quality and handling, especially in midsize or premium sedans, a multi-link suspension is ideal. It allows independent wheel movement, reducing body roll and improving comfort, but it's more complex and expensive. For performance cars, go with double wishbone or multi-link suspensions on both axles. These offer high precision in wheel control and maintain optimal tire contact during aggressive driving. For SUVs and off-road vehicles, McPherson struts in front and multi-link or solid axle rear setups are common. They balance comfort with ruggedness. Add air suspension for ride height adjustability and load leveling. And finally, for trucks and heavy-duty vehicles, a leaf spring or solid axle setup is preferred. It handles heavy loads reliably and resists wear in rough conditions.